Okay, so in this video, we're going to look at Unit 4 Applied Maths, the Independent Task 1. Okay, so here are our 5 topics on the front page. So we have 2A tables, a normal distribution, uniform distribution, hypothesis testing, and then conditional probability using a formula, and also a bit of Venn diagrams we could have used for this. Okay, so you should have already had a go at the questions. You should have got to a certain level of support. So the usual things, if you just looked at your books or you just watched the video, you're at level 1 or level 2. If you were seeking out either advice from a friend, that's level 3. And if you had to go to a teacher, that's level 4. Okay, so you should be aware of what topics you may need a little bit more work on than others. Okay, so hopefully this walkthrough will help as well with those kind of topics. So the first one is we've got 2A tables. So we've got a rambling group is made up of 63 women and 47 men. 26 of the women and 18 of the men use a walking stick. Okay, draw a 2A table for this information. So a 2A table is just a way of us presenting this data, okay, in terms of for us to use it for probability. Okay, so we've kind of got 2 columns and 2 rows in this case. Okay, so I've either got their male or their female, and then I also need their total. And then going down, I'm going to have they either use a walking stick, they don't use a walking stick, or their total. Now, it's important we have these total ones, okay, because we're going to use that as an advantage. So I know to start with that there are 63 women. So for the total for women or female should be 63. Then I know there's 47 men. So if I go to the male column, this total down here should be 47. Okay, now I'm going to use the other 2 bits of information. So I've got 26 of the women use walking sticks. So sticks is this one, females is this one. So that's, this number here has to be 26. And then very similarly, the 18 of the men use walking sticks. So sticks and walking men must be 18. Okay, now all I'm going to do is I'm going to use the rest of the using totals and things like that to find out all my missing gaps. So first of all, number of walking sticks, I'm going to add these 2 numbers together. So I get 44. I can also use the fact that the males, there should be 47 of them. 18 of them use a walking stick, so that means that 29 of them are not going to use a walking stick. Same for females, 63 in total. There's 26 who use a walking stick, so 37 who don't. And then let's add up a total for the non-walking sticks, that's 66. Now, we should always make sure both of these totals should add up to make the same amount. Okay, so if I look at these totals here, so I got 44 and 66, that's 110. And let's make sure these 2 make 110 as well, which if I add them, they do. That means I've done it correctly. If I'm getting to that point there, or I'm finding out a missing gap, and I'm doing the final gap, then we need to make sure that both options add or take away to make that number, okay? So you gotta make sure it works in every direction. Right, now we can use this for our probabilities. So the first one is the probability that they use a stick. Okay, so that's probability of an S in my case. So I'm just talking about the total. Number of walking sticks in total is 44. The grand total was 110, so it's 44 out of 110, nice and easy. Okay, now the next 2 are the given formulas. Okay, so our conditional formulas. So the first one is they use a stick given that they're female. Okay, so if I go to the female column, I'm only looking at this column here. So I'm going to isolate everything. I'm only going to look at these numbers here. Okay, which means my total is going to be out of 63. Let me get rid of that. Okay, and then we need to think about what goes on the top, and that's how many people use a walking stick. So that's going to be 26 goes by here. Okay, and then that's why I end up with that one, and we need a very similar one for part 3. So for part 3, we have probability. So again, if I do part 3, if I set up my formula, I got probability that they're male given they use a stick. So this time I'm going to isolate the stick row by here. Okay, so I'm going to change it. It's going to be out of 44 this time. So I'm isolating either my rows or columns when I got givens for this. And I want how many of them are male. That's 18. So that's 18 out of the 44. Okay, so when we've got 2A tables, once we've got it set up, we can isolate rows and columns and use that to our advantage. Okay, so question 2. I put a line here because I'm going to need some extra space, but we've got a normal distribution question. Okay, so it's important when we're reading these kind of questions, make sure you read it all first, and then we can go back through and we can kind of pick out the key bits of information. So a machine dispenses liquid into plastic cups in such a way that the volume of liquid dispensed is normally distributed with a mean of 120. The cups have a capacity of 140, and the probability the machine dispenses too much liquid and the cup overflows is 0.01. Find the standard deviation. So remember, for a normal distribution, we need to know two things. We need to know what the mean is and what the standard deviation is. Now, in this case, I don't know what it is, so I'm going to have to try and find it. But the first thing I need to do, there's no letter defined, so I need to find a letter. Okay, so let X be the volume of liquid dispensed. And then I can have the fact that, okay, that means X is normally distributed with 120 is my mean and sigma squared, because I don't know what my standard deviation is. Okay, now if I'm missing a mu or sigma, I need to consider using Z tables. Okay, so for part one, I define that, don't I? So I need the probability. They've told me that the probability that it dispenses too much is 0.01. So I know some sort of probability is 0.01. Okay, now I know this got a maximum of 140. So if it dispenses too much, it dispenses more than 140. Okay, and I'm going to use Z tables. Okay, that's what I'm going to use here. So the first thing I'm going to do is I'm going to change this to a Z. Now to do that, we use X, which is 140, minus mu, which is 120, all over sigma. Okay, so I've now set it up with a Z table. Now, I have to use inverse normal here, but before I do, I need to make sure it's less than, so I need to flip this around. So if I flip the inequality sign, I leave this side alone. This side, I do 1 minus, so 1 minus 0.01 is going to be 0.99. So that's what I'm now going to use using my inverse normal form, point of my calculator. Okay, so my area is 0.99. It'll automatically fill your Z's. Okay, so remember your Z has a mean of 0 and a standard deviation of 1. Okay, that's why we use it. So if I type it in, I get 140 minus 120 all over sigma. And if I type it into my calculator, I get 2.326. Okay, now I am just going to solve this for sigma. I'm just going to swap these two things over. And I'll type in my calculator and I get 8.6 to 1 decimal place. Okay, so I use the key factor. Obviously, Z's are normally distributed with 0 and 1 squared like this. And I use my area, my inverse normal formula. So now I can answer the rest of the question. So find the probability that the machine dispenses less than 110. So the first thing I'm going to do is I'm going to go back to my distribution and I'm going to rewrite it out. So it's 120 and then 8.6 squared. Okay, if you rounded it to something different, your answers might be slightly different from here on out. Okay, but they should be roughly around the same point. So for part B, I want the probability that the machine is less than 110. So X is less than 110. Okay, and I'm simply going to go into my calculator. Okay, mu is 120, sigma is 8.6. It's less than 110. So that means I want my upper value to be 110 and my lower value to be just some really, really small negative number. And I should get this out of my calculator. Okay, then it tells me 10%. So it says 10%. I know that's 0.1. So I'm dealing with a probability here of customers complaining that the machine does not dispense enough liquid. Find the largest volume of liquid to the nearest millimeter that it will lead to a complaint. So I want the probability that X being less than some amount, and that's 10%, because that's 10% of the people are complaining that it's less than this amount. And again, I got an inverse normal. I know my mu and my sigma, so I can use these values up here instead of my Z tables, type it in, and it's just going to spit me out. So I got 108.98 milliliters. Okay, now I want it to find the largest volume to the nearest millimeter, so that's 109 milliliters. Okay, so for the next one then, we've got uniform distribution. Okay, so we got our those are two kind of like key new ones from this year. Obviously, we still need to remember like Poisson and binomial and things from Unit 2, but these are the two main ones for this one. So I've got Jamil catches a bus to work every morning. According to the timetable, the bus is due at 9 a.m. But Jamil knows the bus can arrive at a random time between 3 minutes early or 10 minutes late. The random variable x represents the time in minutes after 9 a.m. Okay, that's the kind of key bit here, after 9 a.m. Suggest a suitable model and a distribution for x and specify it fully. So obviously I've told you in this one the topic is uniform distribution, so we know that we should be using uniform. Okay, the kind of key thing here is that if we're talking about like a time period, we're probably going to be looking at a uniform distribution, because when we're trying to decide between is it uniform or is it normal, for example, normal we need a mean and we need a standard deviation, whereas a uniform we just need like an average, we just need a time or some sort of like average thing. Okay, so uniform distribution. Okay, so I can say it represents an x, so it's already defined it for me. I now need its two parameters. Okay, so 9 is the number of minutes after 9 a.m. So if it was 10 minutes late, that's 10 minutes afterwards. But if it's 3 minutes early, that's -3. Now you can have negative numbers, and that's fine. Don't feel yourself you have to force yourself to not have a negative number. So I'm also going to draw out the distribution, because we should always do this every time. Make sure we understand what's going on. So it goes from -3 up to 10. Which means I can figure out what the height is, because this area should be 1. This should be 1 over b minus a. So if I take these two away, I get 1 over 13. Okay, so there's me fully defining everything for that. Okay, now part B, calculate the mean. So the mean is e of x. Now again, this is in our formula booklet. It's a plus b over 2. So I've got -3 plus 10 over 2, which is going to give me 3.5 minutes. Okay, so on average, okay, it's 3.5 minutes late. Right, there is no part C. Sorry, go straight to part D. I skipped that one out. Jamil will be late for work, but if the bus arrives after 9:05, find the probability that Jamil is late for work. So if it arrives after 9:05, if I look at 9:05 exactly, that is 5 minutes late. Okay, so if it arrives any time after that, so that's 9:05 up to the top period. So 5 in terms of my bar would be about here. I want everything above that. So I want it between 5 and 10. So I want the probability that x is between 5 and 10. So again, I'm just using area of a rectangle. This is going to be 10 minus 5, that's my base, times my height, which I've already found, which is 1 over 13, gives me 5 over 13. Now, realistically, that's not a nice decimal if it spits it out. If you get that kind of scenario, write both. It's always a good example, or I'd say leave it as a fraction. It's a little bit easier to deal with. Okay, so uniform distribution can be a little bit easier. Okay, the kind of key thing is getting it set up in the first place. Okay, so for question 4, we have our big hypothesis test. Now, this can be worth quite a lot of marks in the exam. Okay, so when it comes to this one, we need to really break it down quite a lot. So climbing rope produced by manufacturer is known to be such that 1 meter lengths of breaking strength are normally distributed with a mean of 170.2 and a standard deviation of 10.5. Find to 3 decimal places. And obviously, normally we do 4. They're asking for 3, so we'll make sure we do it for 3. But again, the first thing, there's no letter to find, so I need to find a letter. Okay, so let x be the breaking strength of climbing rope. That's what it's supposed to be. Okay. Then I can set my distribution. So x is normally distributed with 170.2 and 10.5 squared. Okay. So part A 1 meter length of rope. So find the probability that the 1 meter length of rope chosen at random from those produced by the manufacturer will have a breaking strength of 175 to the nearest kilogram. Okay, now we should remember with normal distribution and with uniform like we did in the other one, we never do an equals to. So we never do the probability that x equals something, okay, because we talk about area. You can't have an area of a line, so it doesn't work. Okay, so we need to think about, they've only told you one number here, but they have said it's to nearest nearest kg, okay, which means I've got bounds. Okay, so the lower bound of it must be 174.5, and the upper bound of it must be 175.5. Okay, so I want it in between these two. So on the probability, it's between 174.5 and 175.5. Okay, and again, I'm going to go to my calculator. I'm going to type in my mu, my sigma, my two values, and I'm going to spit out the number. So 0.034. Okay, so part B, a random sample of 50. So I've got n is 50. Of 51 meter lengths will have a mean breaking strength of more than 172.4. Okay, so I've taken a sample, so I need a new distribution of x bar. Okay, I don't want to know how many of those 50. I'm doing the mean of the 50. Okay, so I've got 170.2. The mean stays the same. Now what changes is your standard deviation. It becomes what you've currently got all over your n. So in this case, 50. Okay, now what I always recommend to do is go over to the side and write out what your sigma is, because this is what you put in your calculator. Okay, 10.5, and you root top and bottom. So if I root the top, I get 10.5. If I root the bottom, I get root 50. Okay, so that's what I'm going to use in my calculator. And I want the probability that my x bar is more than 172.4 for the question. And again, I'm going to go to my calculator. So mu is 170.2. My sigma is 10.5 over root 50. Just be careful typing it in because it puts in a slightly different format. 172.4. I want it greater than this. So 172.4 must be my lower value. My upper value must be some really, really big number. And then I'm going to type it in. Okay. Right. Now, part C, and this little bit of information before it. This is my hypothesis test. Now you'll notice it's only worth 3 marks, so we'll talk about that, okay? But let's get all the information that we need first. So a new component material is added to the ropes being produced. The manufacturer believes that this will increase the mean without changing the standard deviation. A random sample of 50, which is what I used in the question above, and then rope with a break-in strength of 172.4, which again I did in the previous one. Okay, so these two amounts are the same from part B, so I don't need to go do something extra, okay, because I've already done it in the previous question, which is why this one is only worth 3 marks. Normally these kind of questions would be worth like 5, maybe even more, okay? But because it's only worth 3, there's clearly a little trick. Now, some of you may have gone away and done the critical values, compared them, all that kind of stuff, and that's fine if you've done it. You would have had the same outcome at the end, okay? I'm going to use my answer from the previous one. So they want me to perform a significant test of 5% to decide whether the results support sufficient evidence the manufacturer believes the mean strength has increased, okay? So, first thing, H0 and H1. Okay, H0 is your null hypothesis, what is currently in place, and H1 is what they're claiming. Now they're claiming it's increased. Okay, now normally from here I would go away and I'd go, okay, let's do my critical values and all that kind of stuff. But actually, I'm going to look at p-values. I'm going to look at the probability that x bar is greater than 172.4. And I did that in the previous question. That was 0.069. Okay, and what I'm going to do is I'm going to compare this to a sig level. The sig level was 5%. Okay, now this is greater than your sig level. Okay, now if it's greater than your sig level, straight away I can do my outcome. It's insufficient evidence. To reject H0. Okay, and then I need a context bit here. So I'm going to say, so insufficient evidence to conclude the mean breaking strength has increased. Okay, and that's why it's worth so much less marks than a normal one, because I already did this part in part B. Okay, so I didn't need to do it. Now, really, see, the marks from this are coming from, 1 mark is coming from your hypotheses. 1 mark is these kind of 2 lines here, so realizing, okay, that's bigger than 0.05, so that's insufficient, and then another mark for a context. Okay, you've got to make sure you put into the context of the question. Don't just write as insufficient or sufficient. So the final question, we've got condition probability formula. Okay, so we're going to use a little bit of formula and a little bit of a Venn diagram for this one, because they kind of like go nicely together. I've got John and Kaylee play darts in the same team. The events J and K are defined as followed. J is the event that John wins the match, and K is the event that Kaylee wins the match. So I've got the probability of J is 0.6, the probability of K is 0.7, the probability of J union K is 0.8. Find the probability that both John and Kaylee win. Now, if I want them both to win, I want the intersection. Okay, so now I'm going to think about what they've given me and what links the intersection. Now, the thing that links them is your really long formula from last year, from Unit 2. And that's that your probability of your union is the probability of J plus the probability of K minus the intersection. Okay, I'll basically just sub my values in. So the union is 0.8, J is 0.6, K is 0.7, and I don't know this, so I'm going to rearrange it. Okay, so I can work it out now from here. Again, we're in applied, so I'm not getting marked my algebra skills from here. I can just do it. Okay, so I've got this side, so 0.6 plus 0.7, that's going to give me 1.3. I'm going to take away 0.8, that gives me 0.5. So that's my intersection. Now, what I'm going to do now is I'm going to draw my Venn diagram to help me out for the rest of the question. Okay, I don't need to do this, that's fine, but I think it's always helpful. So my intersection is 0.5. All of J should be 0.6, that should be 0.1 over here. All of K should be 0.7, so that's 0.2 by here. Everything should make 1, so I'm missing 0.2 on the outside. Okay, now I'm just going to pick out numbers from it, that's why I've used it. So B, the probability that John wins given Kaylee loses. So the probability that John wins given not Kaylee, because Kaylee is that fact. K is the fact that she wins, so not K will be the fact that she loses. Okay, so if I'm using a formula, this is probability of J intersection not K all over the probability of not K. Okay, on both on top over the second over what is given on the bottom. Okay, so on the top, in fact, let's do the bottom bit, it's a bit easier. Not K. If K is 0.7, not K is 0.3. The top, J intersecting not K. Okay, so that's where John wins, but Kaylee doesn't. So that's just this 0.1. Okay, and again, if I type in my calculator or if we just rearrange it, it comes out as a nice third. Let's leave it as that. It's a little bit easier to deal with. Right, very similar for the next one. That Kaylee wins given that John wins. So same thing again. I want the probability of K and J all over the probability of J. Okay, so again, if I pick my numbers off, J and K is 0.5. I found on the previous one. 0.6 goes on the bottom, so I've got 5/6. Okay, then I've got my final kind of question to do here. This is why it's really, really useful to do a Venn diagram, because you do just pick your numbers off that you need as you need them, okay? So part D, determine whether J and K are statistically independent. Now remember, to be independent, if I time them together, it equals this intersection. Okay, now I've already found its intersection is 0.5. So what I'm going to test with is I'm going to do, okay, what is probability of J times the probability of K? Okay, so that's 0.6 times 0.7. which would give me 0.42, which doesn't equal my intersection, which means therefore J and K are not independent. Okay, so make sure if we're using the independent rule that we're either told they are or we're using it to test whether they are. Okay, we need to find the intersection a different way if that is the case. Okay, so apart from that, make a note of the topics you need to go over. Okay, go revisit them, and I will see you in the next video. Okay, guys? Thank you.